MHF4U. Hello. Lesson 3.9, Applications of Trig Functions, Day 2. Some more trig function fun applications again. The 3-minute review isn't really an application, but it'll get the graphing calculators warmed up for us. So hopefully you tried to do this, and really it's fairly natural what you would do, but I want to, answer some of this stuff down here, show you maybe a few hints and tricks. First of all, if you haven't done the 3-minute review because you didn't have this installed at home or whatever, then make sure you try this at back in class as soon as you get a chance. It is important to be able to mess around with this, like I said. First of all, the first hint is make sure the graphing calculator is in radian mode. And if you press mode, there are a bunch of things here, a bunch of settings, and we see, yes, indeed, the calculator is in radian mode rather than degree mode. So if there's any, you're using it in physics class or some other less important subject where everything's in degrees, then you might want to switch your calculator to degree mode. But it's in radian mode, and that's good. And so to graph this, you might have some junk in there. I just press y equals, clear out the old junk, and I'm going to do a fun one to start. The sine x and cos x are easy peasy. Tan x are right there. You just hit the button, then x. But cosecant, there's no cosecant button, right? And remember, this means inverse sine, inverse cos, not the reciprocal. So how do we graph cosecant? It's 1 divided by the sine of x, right? And if I just press graph here, there's going to be all sorts, it could be any sorts of window settings that are no good, right? And if I did this, it'll look kind of, well, it's not so bad, actually. Pretty close to what we wanted. But certainly, we don't have our nice trig scale, right? We don't have a trig scale, an important point every 3 ticks, right? This is what we're used to seeing is, bop, 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 pi over 2. Bop, 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 pi. Bop, bop, bop. 3 pi over 2, and so on, right? That's what we're used to, and wouldn't it be nice if we could have that to check? And we can't, right? There's a couple of things we can do. One is, if we're okay with the calculator's version of trig graphs, we can press zoom 7, and it'll set up this trig graphs. Now notice, their important points aren't every pi over 6. Their ticks are every pi over 2. And if I go back into the window settings, I can see this negative 6.15, that's negative 2 pi, right? And if I wanted to set it up, I just clear that out and put in negative 2 pi, and I could do that, absolutely. Well, I guess they cut it off a little bit just to make it look nice, maybe. So 2 pi. And then if I wanted the ticks to be every, 3 ticks for pi over 2. Notice their scale is 1.57. That is pi over 2. And just to prove that to you, pi divided by 2, each tick, that scale pi over 2 is 1.57. But if we want it pi over 6, let's just put in pi over 6. And then when I graph it, it's more like what we used to. Notice it appears that the graph has the asymptotes drawn in, but it shouldn't be. What this calculator actually does, it does a huge table of values, and it's plotted one way up here, close to pi, and then it's joined it to the next one that's way down here. So it actually, the calculator thinks this is a continuous function, which is very strange. If I were to put second function, sorry, not second function, just hit trace, and look at there, at 0 it is undefined indeed. And if I were to put in pi, skip to the point where x equals pi, it's undefined there as well, even though it looks like there's a vertical line. All right, that's it with that. So play around with that. It's good, clean fun. And then on to today's stuff. Now today's stuff is more applications, and in fact we're going to blend and bleed this into this lesson into our talk on trig functions and rate of changes as well. And we're going to use this moon phases example. And this is similar to the one we did the last day about the owls, where it's kind of a story. So you need to read. I'm not going to read this to you. You stop the video, read this. It should be right in front of you. If it's not, or if it's not clear because your printer's no good, I'll go down a little bit so you can read it. Maybe that went too fast there. Again, you can pause if you like. And there's the end of the note. All right, so again, pause if you want, go back. Hopefully that's clear enough to read. The activity today is, and you're going to pause the video and do this as well. What I want you to do is on this sheet, and it looks strange, but this is the moon over several days. What does it say? It says over several days in, no, it doesn't say, but I had it read here somewhere. This is over several days in January 2007 or something like that. Anyway, it's the moon. And the moon, you know, from day to day, it'll be showing either more moon or less moon, depending on whether we're getting close to a new moon or full moon. Your task, and this is the day of the month, is just to write in what percent of the moon it appears like it's showing. And I know your photocopy isn't going to look very good, but you should be able to see here pretty well what percent, and it'll just be a guess. So for instance, you might say this isn't quite 50%. 50% would be the half moon, and it's a little less than that. I'd say that's maybe about 40%. And you're going to go through and you're going to guess. Now it's hard for, like, all these look like new moons, look like there's none showing, but and same as the full moons look like the full moon for a whole bunch of days in a row. Obviously, there's only one that's 100%. There's only one day that there's a new moon. And the kind of the best way to think about this is, I can see a little sliver there, and I can see a little sliver there, maybe a little sliver there, I don't know. But somewhere in between these is going to be the new moon, right? So maybe here, right? Because that's in between these two, 5 days. This is maybe there I'll say that's 0, and then just guess how, even though it's hard to see anything on this one, maybe that's 1%. But how could I tell 1% of the moon? I can't really. I'm kind of guessing, and so on. So you go ahead and you try, and you put in this data. You pause the video and you do this. I will actually allow you time to do this, and I'm going to pick up the rest of this activity in part 2. Again, one of these is the new moon, or the full moon, right? Full moon. Looks like this whole week is all full moon. There I can see a little bit of shadow. Maybe over here I can see a little bit of shadow. So I might call this the new moon. This is 100, or the full moon. This is 100%. You get the idea. You pause the video and do this. We'll pick it up in part 2.